Hello, my viewers, and welcome to this session. In this session, we look at an example on differentiation using the method of first principles, that is the definition of derivatives. So suppose that y is equals to a function of x. Then the derivative dy by dx, which we also denote by f prime of x, is given by the limit as h approaches 0, f of x plus h minus f of x divided by h. This is what we call the use of first principles, or the definition of the derivative. So we will just want to find, to make use of this to find the derivative of a function. That is, we just want to do an example. So my aim here is to do an example using the method of first principles. So you are given a function f of x is equals to, say, 2x divided by 3x plus 5. The problem is to use first principles to find the derivative dy dx or dy by dx, which we shall be denoting by f prime of x. So we want to use first principles. So we state the method. This is the limit as h approaches 0, f of x plus h minus f of x divided by h. This is the definition of logarithms. So in our case here, f of x is equals to 2x divided by 3x plus 5. So when we write f of x plus h, then this will be 2 into x plus h. Remember, here we are replacing x by x plus h plus 5. So we can write this one as 2x plus 2h, and the denominator can be expressed as 3x plus 3h plus 5. Then we can substitute back. So f of x plus h minus f of x, then divided by h. So we get f prime of x is equals to the limit as h approaches 0. So we get f of x plus h is 2x plus 2h divided by 3x plus 3h plus 5. Then we subtract f of x, which is 2x divided by 3x plus 5, and the whole of that is divided by h, so we can just multiply by 1 over h. Next, we simplify. We can put these terms at a common denominator, which will be the product of the denominators here. So we write f prime, which is the limit as h approaches 0. We have the denominator, we can write 3x plus 3h plus 5 multiplying 3x plus 5, and of course we have h. So the numerator becomes 3x plus 5 multiplying 2x plus 2h minus 2x multiplying 3x plus 3h plus 5. So this is how we can write our expression. Now if we expand the numerator, we multiply out the terms in the numerator, then we get the limit as h approaches 0. We get this will be we can just multiply out here. So 3x times 2x would give us 6x squared. Then we have plus 6xh, then plus 10x, plus 10h, then minus. The next here we have 6x squared plus 6xh plus 10x. This one is divided by 3x plus 3h plus 5 multiplying 3x plus 5 multiplying h. Now, the numerator, we can simplify. So we say that we have 6x squared minus 6x squared, which is 0. 6xh minus 6xh is 0. Then 10x minus 10x is 0. So the numerator, only 10h remains. So we get the limit as h approaches 0. The numerator, we get 10h. And the denominator, we have 3x plus 3h plus 5 multiplying 3x plus 5 multiplying h. So you notice that h will cancel out. You see h appears in both the numerator here and the denominator. It will cancel out so that we get the limit h approaches 0. We have 10 divided by 3x plus 3h plus 5 multiplying 3x plus 5. So now we take the limit as h goes to 0. If we take h to 0, now we will get the numerator is 10 and the denominator is 3x plus 3 times 0 when h goes to 0 plus 5 multiplying 3x plus 5, and this becomes 10 divided by 3x plus 5 multiplying 3x plus 5. Notice that the term here, 3 times 0 is 0. So that we get 10 divided by 3x. Sorry, this is 3x plus 5 raised to the power of 2, which is the derivative of that function. This is the derivative of that function. Notice the steps. If we're taught to find the derivative using first principles, the first step is to write the definition of the derivative. The limit as h approaches 0, f of x plus h minus f of x divided by h. We can always replace h by delta x, meaning a small change in x, but I'll prefer to use h. So then the function f of x is given. So when you write f of x plus h, you just replace x whenever it occurs with x plus h. So that is what we have here. Of course, we can open the brackets in the numerator to get 2x plus 2h, in the denominator to get 3x plus 3h plus 5. Then we substitute back and simplify. Once you simplify completely, the h occurring in the denominator should cancel out, and then you take the limit by setting h as 0, taking h to 0, and then simplify that to get the derivative. So this method is what we call the use of first principles to differentiate a function. So basically, that is what we call first principles. So we stop at that for this session, and I hope you find this method useful and it will enhance your understanding on the methods of differentiation. Thank you for watching.